Have you ever noticed that Claude, despite being called the best AI tool out there, doesn't give noticeably different results than the other models? I thought the same thing until I found how Anthropic's own team actually prompts Claude, and the difference was immediate. So in this video, I'm going to show you all 6 techniques so you can start getting the same output their own engineers do. The first thing Anthropic engineers do that regular users skip entirely is telling Claude who it is before asking it to do anything. Anthropic's own documentation calls role prompting one of the most effective ways to steer Claude's behavior. And the reason it works so well is that a single sentence defining Claude's role changes the tone, the depth, and the structure of every response that follows. If you type "explain how a balance sheet works," you get a basic explanation that could come from a textbook. If you type "you are a CFO with 20 years of experience explaining financial concepts to non-finance executives, explain how a balance sheet works," the response changes completely. The language is simpler, the examples are corporate, and the structure matches how a real CFO would break it down for a colleague who spends their day in spreadsheets. That one sentence didn't add any information about balance sheets. It changed how Claude thinks about delivering the answer, and that framing carries through the entire conversation. Anthropic's official prompting guide treats this as the foundation, and their exact recommendation is to think of every prompt as instructions to a brilliant but literal new hire on their first day. They'll do exactly what you say, so the role definition is what tells them how to interpret everything that follows. You can set this permanently through custom instructions or projects, so the role definition loads automatically on every conversation without you typing it each time. Once Claude knows who it is, the next question is whether it can actually read what you're giving it, and this is where most prompts quietly fall apart. And by the way, I put together a free playbook with all 6 techniques, copy-paste templates for each one, and 5 superstructured prompts that combine everything. You can grab it in the description below. This is the technique that Anthropic's documentation highlights more than any other, and it's the one that almost nobody outside of their engineering team actually uses. Anthropic's own documentation says XML tags make a measurable difference for prompts with multiple components and confirms that Claude was specifically trained to parse them as structural markers. Their internal testing shows structured XML prompts produce 20 to 40% more consistent outputs compared to the same instructions written as plain text. XML tags are just labels you wrap around different parts of your prompt, like putting your background information between an opening and closing context tag. If you've ever seen HTML on a website, it's the same idea, just used inside a prompt instead of a web page. So instead of writing one long paragraph that mixes your context, your instructions, and your constraints together, you separate them with tags. You wrap your background information in context tags, your actual task and instruction tags, and your formatting requirements in output tags. And Claude reads each section as a distinct input instead of trying to parse a wall of text where everything runs together. The reason this works is that without tags, Claude has to guess where your context ends and your instructions begin. With tags, there's no guessing. Each section has a clear boundary, and Claude processes them in order. I tested this with the same prompt written 2 ways. The plain text version asked Claude to analyze a quarterly report, focus on revenue trends, keep the format concise, and flag any risks. The XML version had the same information split into context tags for the report details, instruction tags for the analysis task, and output tags for the format. The information was identical in both versions, but the XML version came back cleaner, flagged risks I didn't catch in the plain text version, and matched the format I asked for without me having to correct it. You don't need to memorize specific tag names. Anthropic says there are no correct tags. You just use names that make sense, like context, instructions, examples, and constraints, and stay consistent throughout your prompts. The difference in output quality is immediate and obvious the first time you try it, and once you see it, you won't go back to writing prompts as plain paragraphs. Structure gets Claude reading your prompt correctly, but there's still a gap between Claude understanding what you want and Claude knowing what the finished product should look like. Anthropic engineers include examples of the output they want inside the prompt itself, and this one change eliminates most of the back and forth that regular users experience. The technique is called few-shot prompting, and it works by showing Claude 1 or 2 examples of exactly what the finished output should look like before asking it to produce a new one. Instead of describing the format you want in words, which Claude then interprets and often gets partially wrong, you paste an actual example and say, "produce something that follows this structure." If you want Claude to write product descriptions in a specific style, paste 2 examples of product descriptions that match what you're looking for, wrap them in example tags, and then give Claude the new product to describe. The output will match the tone, length, and structure of your examples far more accurately than any amount of written instructions could achieve. This works because Claude is better at pattern matching than instruction following. Telling Claude, write in a casual but professional tone, keep it under 100 words, and lead with the benefit is vague enough that Claude interprets it differently every time. Showing Claude 2 examples that demonstrate all of those qualities gives it a concrete target to match. Anthropic specifically says that positive examples showing how Claude can communicate tend to be more effective than negative examples or instructions that tell the model what not to do. Showing Claude what good looks like works better than telling it what to avoid. The combination of XML tags and few-shot examples together is what Anthropic calls superstructured high-performance prompts, and it's the default approach their engineers use for any task where consistency matters. These three techniques together handle most tasks, but they hit a ceiling the moment the task has too many moving parts for a single prompt to hold. When Anthropic engineers tackle a complex task, they don't try to get everything done in one massive prompt. They break it into a sequence where each prompt builds on the output of the previous one. The reasoning is straightforward. A single prompt that asks Claude to research a topic, analyze the findings, draft a report, and format it for a specific audience is asking 4 different cognitive tasks in one pass, and the quality of each one suffers because Claude is trying to hold all 4 in context simultaneously. Prompt chaining separates those tasks so each one gets Claude's full attention. Prompt 1 handles the research, Prompt 2 takes the research output and analyzes it. Prompt 3 takes the analysis and drafts the report. Prompt 4 formats it for the audience. Each step is simpler, the output is higher quality, and if something goes wrong at step 2, you fix it at step 2 instead of rerunning the entire process from scratch. Anthropic's documentation includes a specific example of this. A medical research summarization workflow uses 3 chained prompts. The first summarizes the paper, the second reviews the summary for accuracy on an A through F scale, and the third improves the summary based on the review feedback. The final output from 3 focused prompts is consistently stronger than what a single summarize this paper accurately and comprehensively prompt produces, because each step catches errors the previous step introduced. The chain doesn't have to be long. Even splitting a task into 2 prompts, one for the thinking and one for the output, produces noticeably better results than trying to do both in one shot. Chaining gives each step full attention, and there's one more setting that takes the reasoning quality even further. Claude has a built-in reasoning mode called extended thinking, and Anthropic engineers turn it on for any task where the first intuitive answer might not be the best one. When extended thinking is active, Claude works through the problem step by step before giving you the final answer. You can see the entire reasoning process, which means you can identify exactly where Claude's logic is strong and where it made an assumption you disagree with. The difference between standard mode and extended thinking on a complex analysis is similar to the difference between asking someone for a quick take versus asking them to think it through carefully and walk you through their reasoning. For everyday tasks like drafting emails or summarizing articles, standard mode is fine. For anything involving multi-step logic, financial analysis, strategic decisions, or technical problem solving, extended thinking produces output that's measurably more accurate. Anthropic's own team says, "We expect effort to be more important for this model than for any prior version of Claude, and they recommend a minimum of high effort for anything where accuracy matters." In Claude, you can toggle this on for any conversation, and the trade-off is that responses take longer because Claude is doing more work before it answers. A good rule of thumb is to use extended thinking whenever you catch yourself second-guessing whether Claude's answer is actually correct or just sounds correct. If the question is simple enough that you'd trust a quick answer from a colleague, standard mode is fine. If it's complex enough that you'd want your colleague to think it through before responding, turn on extended thinking. The investment in time pays back in accuracy, and for high-stakes work where getting it wrong costs more than waiting an extra 30 seconds, extended thinking is the default choice. All 5 of these techniques improve the output you get right now, but the last one is what makes the output keep getting better over time. The last technique isn't about any single prompt. It's about how your entire Claude setup improves over time. Anthropic engineer Barry Zhang described the philosophy behind how Claude is designed to work. Our goal is that Claude on day 30 of working with you is going to be a lot better than Claude on day 1. That improvement doesn't happen automatically in Claude's chat interface. It happens when you treat every imperfect output as a signal to update your instructions. When Claude gives you something that's close but not right, instead of editing the response and moving on, ask whether the issue is a one-off or something that's going to keep showing up. If it's going to keep showing up, update the prompt, the role definition, the examples, or the constraints, so the same mistake doesn't happen next time. I started doing this with my weekly reporting prompt 3 months ago, and the difference is visible. The first version needed 4 or 5 corrections per report. The current version produces a draft I can send with 1 or 2 minor tweaks because every time I found an issue, I updated the prompt instead of just fixing the output. If you use Claude projects, this works even better because the refined instructions persist across every conversation in that project. You update the project instructions once, and every future conversation benefits from the fix without you remembering to include it. That's the difference. Regular users fix the output. Anthropic's approach is to fix the process that produces the output, and that's how Claude on day 30 actually becomes better than Claude on day 1. And the extended thinking technique from earlier is actually just one of several Claude settings that most users have never opened. I found 5 more that change how Claude handles everything from memory to formatting to how it processes your files, and I broke all of them down right here. Thank you for watching, and I'll see you in the next one.